Good evening, ladies and gentlemen, I am the Sarcastic Barman and welcome to my channel. Strangely, this isn't going to be a video by me, this is a mirror by Leigh. And it's awesome for any of the 5G nutters out there, like Mark Steele, who basically this is directed towards, will very much enjoy this. So enjoy the video, links to his channel will be down below. Please go give him a like, a share, a comment, go check out his other videos. Well worth having a look at, very underrated channel. Enjoy.
Hello, welcome back to Leigh's lab, back in the inner sanctum because the basement is still freezing, but I have something really interesting to show you now. I've been looking at the Harvard Engineering Magnode for the past few videos, especially the antenna system on it and how the antenna is built, and we've been testing the coverage and the radiation pattern of the antenna. What I really wanted to do though is to show you the Magnode actually working and turning lights on and off, which is what it is meant to do. Unfortunately, the Magnode that I purchased, which I've been looking at, was slightly broken when I took it to bits to get the antenna off. And that's because, as we saw in the other videos, it's covered in this conformal coating. And what the coating does is it coats the whole thing inside and stops water getting into it. Unfortunately, when I took it to bits, there are actually 3 circuit boards in the device. When I prized the circuit boards off very, very carefully, because all the coating was on there, it wouldn't come off properly. These are meant to be connectors, they just stuck. And I pulled all the tracks off the PCB and it was ruined. So good for the antenna, that wasn't affected, but the circuit boards, they were destroyed, which is a bit of a shame. Fortunately, these are $8.99 on eBay, and so I got another one. But what's really cool is I managed to find one of these on eBay, about £20. This is a WiMAX on-site tester, and this is the device that the engineers would use when they install these on the lampposts, just to make sure that it's working and that they install it properly. I haven't tried this yet. I've read the manual, so I know what we need to do. But this is the first time I'm going to try this and actually, hopefully, see this thing working and doing something. So what we're going to do is we're going to use it to turn on and off this LED light here. It's about a 5-watt light. I have a cable coming here. This is a main supply, which I just plugged in. And all we need to do is to connect this to the neutral here. It's unplugged, that's good. Don't want to get a surprise. And the live in here, and that's it. So there's 3 wires that connect to the Magnode here, and I'll show you on this PCB. This is the PCB from inside here, the one I broke, and this is the power control board. What we have here, this is the live and neutral power supply to the whole thing, and what I'll do is I'll do another video in maybe in a couple of days time, and we'll tear this down properly and we'll reverse engineer the whole thing, which would be really good because then you can see exactly what's inside and we'll look at all the chips and what they do, etc. But what we have, the live and neutral come in. The live goes via a little shunt here. With that shunt there, they can measure the power that the lamp's using. So that's really good because it means if a light should be on but it's using no power, it's faulty, and they can detect that and they can send people out to have it replaced. The live comes in here, it comes around here and it goes via this SCR and this relay here, and the switched output comes out of the relay across the track here and into this red cable, which we have connected up to our light. I'll put the light just over here. It's bright enough to see, but if I have it here, it'll just swamp the camera and you won't see anything whatsoever. When we've done this, what I'll do is I will hook it up to a spectrum analyzer on a software-defined radio, in fact this one here, and we'll be able to see, we'll be able to capture what happens when it actually transmits. So we'll be able to see the transmission on the screen and have a look at that as well. So this device only actually connects to the Magnode when the Magnode has just been power cycled. that prevents people like me from walking down the street with one of these and randomly turning all the lights on or off. So that's a good idea. But what should happen, if it all goes to plan, is if I select automatic here, I read the manual just to make sure I don't fluff this up. And if I turn automatic on, the devices will then listen for the mag node. So it's now listening for mag node. If I plug the mag node in, it will go through an automatic test. So plug it in, the light turns straight on, so it's default on. It's found the mag node. This is fantastic. Lamp off test. Here we go. Yes, lamp is off. Lamp off test OK, so it's measure the current. It knows the lamp is off. Lamp on test. Any moment now. Yes, lamp is on. And I think what it should do now, it will measure the power there. It's got request power. It's now going to request the voltage and the current draw, or the power draw in watts of the lamp. And we should see about 5 watts and about 240 volts, all being well. Any moment now. Now sometimes these operations are a bit slow, and the reason why it isn't instant, I mean, if you're at home and you have a remote control for your lights, you expect to press a button and the lights turn on, and you press the button, the lights turn off. That's because whenever you press the button, as soon as you press bip on your remote control, it transmits immediately, and the lights receiver receives that and it does what you told it to do. This is very different. This is designed to have maybe thousands of these in lamps down the street. Thousands, probably a bit too many, maybe 100 or so at a time. We receive some power. We've got 238 volts, 5.4 watts. Perfect. But yes, so you'd have maybe 100 of these to one of the little base stations, and if they're all transmitting at once, or randomly, it'll be a disaster. They'll all clobber each other, they'll all stamp on each other's feet and interfere with each other, and it will never work. So these devices, designed to have lots and lots of little devices on the network at the same time, they have a very low, what's called a duty cycle. The duty cycle tells this device here how often and for how long it can transmit. And the duty cycle, actually, for any device in this frequency is 1%. So that means this device here can only transmit for 600 milliseconds every minute. So it can only transmit less than 1 second, just over half a second every minute. And it only transmits 25 milliwatts. The reason it takes a little bit of time is because this device doesn't want to transmit all the time. It's not allowed to. It has to cooperate with maybe hundreds of other devices all around the area. So WiMAC and LoRa and all the related protocols, Leigh Mirror, etc., they're really, really slow. There's no way this is ever going to do anything like sort of send CCTV images or any live data, because the network is just designed for really simple signals like light on, light off, and that's it. So yes, so now we have a power reading, and the power reading it's really good because it means that if the light should be on but you have no power going to it, then it's faulty and they can send an engineer out to get it fixed. There are actually a few versions of these devices here from Harvard Electronics. Before I touch it and get a zing, I will just turn the power off, because that would be ruinous to my day. There's a few versions. This is the really basic version, which just turns lights on, off, and gives you a power reading. There's another version of this which looks almost identical. It has another socket on, and that extra socket is for what they call in the industry a presence detector. Not Santa Claus presence, but the presence of people. That could be something like the little passive infrared movement sensors you get in alarm systems. And the idea of that is that rather than having street lights that are controlled centrally, then they all turn off and they turn on at whatever time you set them up to turn off and turn on again, you can set the lamps with these presence detectors to only turn on when somebody's there. But if you look at the Harvard website, which you can't directly, you have to look on the Internet Archive because they sadly went bust a few years ago. Look on the archive of their website. The presence detector is a completely separate unit which should mount on the lamppost and point down to where you want to try and sense people's presence, and plugs into this device. So the claim that Mark Steele made, that this is scanning urban radar, is ludicrous. And you just need to Google and have a look at, I think it's called the iNut, or the iNode from Harvard Engineering, and it tells you that you need an external device to do that sensing. It's not built into here whatsoever. The other version of this is a little black box, and it's smaller because it hasn't got this main switching circuitry in here, because it is designed to control the power supply for an LED light. And they are a bit more interesting because they can not only turn the lights off and on, they can also dim them. So if you combine dimming with presence detection, you have lights that are on but dimmed all the time, and they only go on to full brightness when somebody is either walking in the alleyway or the pavement, or vehicles are using the road. And Mark actually has some videos that show that. They show cars going down the road and the lights only go on when the car is down the road. At other times they're turned off. That isn't scanning urban radar. It is this thing called presence detection. It's a separate unit that plugs into one of these devices, and I think it's really quite cool. So there we are. That is what the device does. We have seen it turn things on and turn things off and measure power. And what I'll do now is I'll get this reconfigured a bit, and I will connect it to my spectrum analyzer here using this little software-defined radio, and we'll have a look at what it transmits and what that looks like. Hold there, I'll be right back. We're back, and I have the spectrum analyzer here. I thought I'd try it out quickly, and it transmits so quickly that it's really hard to see it on the screen here. So what I've done is this program here. It is called SDR Console. It's really cool. It plugs into one of these little RTL SDR devices here, and it can actually record the signal that it receives from the air. And what I've done is I've recorded the signal that it received off the air, and you can see it now on the screen. So you can see that the frequency is right in the middle. It's 869.550 megahertz. 869.5 is about there. That is about where it should have been, according to some of the specifications that I've seen. It's not the best signal I've ever seen. There is, you look at the left-hand side here. There's lots of noise here. There's lots of noise here. You'd expect the signal to be, cutting off here quite nicely and cutting off here, but it is produced by a fairly cheap, mass-produced, very general-purpose RF chip inside the device. And actually, if you look at the peak here and the lowest levels here, there's quite a margin there, so it's not too bad really, but it just looks messy on my analyzer here. So that's what it looks like. What I'll do now is I'll get it all plugged in, and we'll see it live, because you can then see how quick the transmission is. Here we go. Okay, so we're receiving on 869.5 megahertz. All the little peaks here that you can see, that is because I am in a room with cameras and computers and all sorts of things, and it's really noisy. Okay, so we're looking for a signal about here in the middle. Keep your eyes peeled and finger on the pause button, because it is lightning fast. What I'll do is I'll let it go through the whole test procedure again, and you'll be able to see the communications that the Magnode is producing. You won't see the comms from this device here, because I've actually put the Magnode and the SDR antenna into a little bit of a Faraday cage to try and get some of this nasty noise down. Let's go. There we are. You saw that then? Oh, I didn't have the, oh, it's found the mag node. Oh, it's transmitting. There we are, excellent. Initializing, lamp off test. There we are. Lamp on test. And it's now requesting the power, so it's going to get a reading of the voltage and how many watts the lamp is drawing right now. What I'll do is I'll make another video in a couple of days' time, and I say we'll tear down the mag node and reverse engineer the entire thing and see exactly what makes it tick. We'll look at all the chipsets inside, look at how much power they can transmit, look at the capabilities, look at how the this main switching power board works. And then I've had quite a few people ask me in the comments and on Facebook how the software-defined radios work and whether you can use them where you are in your home with your PC to get an idea of what kind of signals are around you. And the answer is yes, absolutely you can. In fact, more than that, you can use this software here. This is freeware, so it's free software. The little dongles, you can get those for about 15 or 20 pounds, and you pretty much just plug it in and install the software and the drivers, and you have a radio that can receive from 1 megahertz to 1.8 gigahertz. And you can run the spectrum analyzer. You can look at LTE signals, 5G signals if they are below 1.8 gigs. You can look at GSM signals. You can receive walkie-talkies and CBs and pagers and decode them, and it's really interesting. So I'll do probably a couple of videos about that. One, a quick SDI intro, and then we'll do a bit more of an in-depth dive, maybe after a few weeks when you've had a chance to buy one yourself, and have a look at what kind of things you can do with a software-defined radio. That's it. We've seen the mag node. It turns lights on, it turns them off. We've seen it transmit. That's all from me. If you're American, have a great Thanksgiving. Goodbye.